Our first presenter today is Naty Clementi. She's a senior software engineer at Voltron Data. She's a former academic with a master's in physics and PhD in mechanical and aerospace engineering. She is currently contributing to Ibis, but in the past has contributed to and maintained Dask. She's also a member of PyLadies and one of the directors of Women Who Code in DC.
Oh, what it was that? Yeah. All right. Thanks, Max, and thank you everyone for coming today. So I'm gonna get the started time so then I don't go off. I hope you like birds because today we're going to be talking about Ibis and DuckDB for geospatial applications. If you don't like birds, I hope at the end you like them. And if you want to leave, I'm not going to be offended. So first of all, let me just introduce myself. As Max says, I'm Naty Clementi, and I'm a software engineer at Voltron Data. And this is where you can find me on the internet. And yes, I get to work on Ibis. We're going to get a little bit more into Ibis in a bit, but just a quick show of hands. Who writes SQL or PostGIS for work? All right, more than half of the room. Who writes Python or pandas or GeoPandas? Okay, who writes both? Nice, so we have a good amount of hands in there. Who knows about DuckDB or what DuckDB is? Okay, nice, loving this. Everyone kind of knows about it. Who has heard about Ibis? Okay, nice, 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 awesome. So a little bit of motivation behind like why this talk and then maybe why something like DuckDB and geospatial components exist is that geospatial data has become more and more prominent in pretty much everywhere. And we have like use cases ranging from location-based services to environmental monitoring to something like optical fiber network rollout plans, whatever that means, but this kind of data is like everywhere, so we want to like process it somehow. And data keeps growing, and it doesn't fit in RAM most of the cases. So GeoPandas is great, but sometimes we're limited by RAM, and then we would like to maybe work on our laptops or not getting a huge machine on AWS or a cluster and deal with all those stuff. And there have been a lot of developments in like more formats to improve like geometries and then make things fast, like GeoParquet and GeoArrow. So all of this makes it like really appealing for something like DuckDB to think about geospatial stuff. So what is DuckDB and why maybe you should care? So DuckDB is a fast in-process analytical database. It's open source. And I think like probably we all know what open source is, but maybe all the words that I've just said, you have no idea what they mean. So what it means is like it's designed to support analytical query workloads like aggregations over entire tables or joins between several large tables. You can think of it as a SQLite for like analytics. There's a DuckDB talk on Friday at 1:15 p.m. that our friends at Mother Duck are going to be giving. They're definitely going to do a better job at explaining what DuckDB is, so I would encourage you to go there. But on a nutshell, it's like we have a column engine which supports parallel execution and allows us to process large in the memory workloads. We don't need a server, so this is kind of like a file on your laptop, and then all the setup of something. If you work with Postgres, it's like it's not there. Now, the other important thing is the folks at DuckDB have been making things hella fast, and in the last 3 years, they have become from 3 to 25x faster, and thanks to Alex Monahan for this plot. I took him from a blog post of him. He's going to be giving the talk like in the afternoon, so Friday. So go and check him out. And then now also that means that we can process like 10x larger data sets. So something that probably you couldn't process on your laptop before, now you will be able to. Now, okay, cool, all about DuckDB, but why like DuckDB and geospatial? So spatial queries involving like geometry, predicates, and relations translate really well into SQL. So it was kind of like natural to think about doing this stuff with DuckDB. And the one thing is, the folks that have been working on this, especially big shout out to Max Gabrielson, who is like one of the main, if not probably the only person at the moment working on DuckDB spatial extension. They have made sure that instead of reinventing the wheel, just like writing things that most of them are implementing functions based on the trifecta of foundational geospatial libraries, like Geos, GDAL, and Proj. And when possible, make it like super fast, and when now just like kind of keep using what we have. And basically this allow us to like leverage, in the case of GDAL, leverage GDAL, and then like support 50 plus geospatial data formats. So then now you have a situation when you can mix and match your geospatial data with also your tables that are not geospatial, and then get to do beautiful things that we're gonna see in a little bit. Now I'll tell you all this, but then it says, okay, who are you? Like Max says, there are no geospatial credentials on my background, but there are some people that do have those credentials, and they also use DuckDB, and they have been saying amazing things about it. So big shout out to Dr. Wu. I don't know if he's in the room, but hey, there we go. Dr. Wu, I've been learning a lot from your materials. Dr. Wu has like an amazing course on YouTube, so please go check him out. Also, he has a talk on Friday. He's going to be talking about some of the cool things that he's been doing. But basically, he went on some workflows from that 20 gigabytes in total he has, from running hours to a couple of seconds. So it was, okay, he seems like he has a lot of followers, right? So he has to know something, right? Isn't it that how we measure this day, like knowledge and stuff? Then on another workflow, it had like 75 gigs of national wetlands inventory, and then also went from like processing on like hours to seconds. So it's like, okay, well, this seems like a good thing. Then we have Matt Forrest at Carto. Has been doing amazing content. I took some inspiration from him to do some of the demos that we're gonna see soon. So big shout out to him. If you're like learning about this, he has a cool YouTube thing, also followers, so you can go and check it out. And another person that has been doing amazing things is like on the plotting side of things, because we have all these geometries and stuff, but then I don't know, I like plots, I like maps, so then we can just plot them. And Kyle Barron also has a talk on Friday, so please go and check out and learn about Longboard there if you need to do plots, especially on a Jupyter Notebook or Jupyter Lab, and leveraging like GeoArrow and GeoParquet to make things like kind of run fast, and then with DuckDB too. So, but what about SQL? Because I just told you all this rant about DuckDB, and then you said, well, but I just don't want to write about SQL. You're like, yeah, no, I mean, we kind of like are on a Python conference, so it's like, why would we do that? Don't worry, we got you. Here's the other bird, come to your salvation. So that's where Ibis come from. Ibis is an open source library, portal library for data wrangling. It's like has an interface with 20 plus backends, most of them SQL backends, but also backends like pandas and polars. And it has this thing called deferred execution model. I'm not gonna get too much into it, but the important thing is Ibis is open source, it's independently governed. There are all these beautiful people working on it, and even more people working on it that don't fit in the screen. And we have all these backends that integrates with. For the geospatial specific case, Ibis integrates well like Postgres. It has also the DuckDB backend that we're just going to be seeing today, and like BigQuery. So if you ever done like some SQL on PostGIS on functions that are like ST, like a special type things, and we'll probably have a function on the Ibis end that kind of replicates that behavior. So I said very quickly about this execution model. So Ibis in a nutshell, it's just like in an eggshell maybe. So how does this work? And this is like a very 101 Ibis super fast introduction. So what we have here is you have your local, like let's say your laptop, you want to write Python code, so you're going to write something like that looks like dataframe-like. We're going to see a demo in a bit. We connect to a remote engine, or it could be also local, like DuckDB. And then we just say, hey, do you have a table called ratings, for example? And they say, yeah, I have it. And instead of dumping the whole table to my local machine, it will just send me the schema. And with that schema, we actually build a deferred expression. We validate it, compile the SQL, send the SQL to the engine, execute it in the engine, and then get the results back. So that's Ibis in a nutshell, or just new term I just created. If you want to learn more about Ibis, my colleague Gail Forsyth is going to be giving a talk about Ibis and get into like the weeds with Ibis. Is tomorrow at 1:55. He's an amazing speaker, so I will encourage you, if you want to have a good time, go and see him. So now it's like demo time. So all this talking, and then like now you're like, okay, how do we do these things? So let me, where is this? Okay, oops. All right, so let's start with, is that big enough? Probably not. There we go. All right, so here what we're gonna be doing is working with a DuckDB database. Again, big shout out to Dr. Wu. I took the data from one of his courses and started playing with it and making some plots. And in this case, we're gonna be using Ibis. So this data is some New York City data. So I'm gonna import it as a database. And then we'll see that there's like a couple tables. We have some information about homicides, some neighborhoods, some streets, and some subways, stations in there. And what we're gonna be doing is I'm gonna look at a subway station, and then I'm gonna kind of grab an area around it, and I wanna see what are the streets around it, and then I'm gonna check if there was some incident in that area. So the way we do that is first we kind of check out our subway stations. So like the way that we do operations in Ibis instead of like writing SQL is we get a table. So this table has like many columns, and at the end you'll see this like geometry column, and this is like a different data type that you might be used to. So we have in this case points that are like coordinates or where the stations are, and a way of checking, let's say grabbing one of those stations is like when you will do in SQL something like select from and then a where clause, then we do a filter. So we filter, and then I'm looking at the station called Broad Street, just because I grabbed one. So now we have this one thing, and then we have that geometry. So if we just like kind of check the geometry, it's like a point. This is on a projection. For those that are familiar with Geospatial, it's like things are not flat, so then we have different projections. I don't remember the name or the number of the projection, but it's at the top of the notebook, and I'll publish them later. So we kind of just get those coordinates, and then now, let's say that I want to find in which neighborhood is that station. So I can grab now the boroughs table and then see where that station is by doing some intersects operation. So I got the boroughs table, and then as you see here is like, these are, I'm just gonna close this. These are some polygons. So this kind of like what delimits the areas. And we can check, okay, where does it intersect, like my dot, where I have the station with like the geometries of the boroughs. So we can see that that station is in the financial district. I'll trust this. I don't know where the stations are in New York, but data says so we'll believe it. We can check like streets nearby. So one way of doing that is like we grab our like streets data, and then we can see with the operation D within, which is like within a certain distance of that point, which are the streets that are around. So once we do that, we see that there are like 3 streets. And let's get to the sad part. So now I want to look, okay, near that area, did something unlikely happen that unfortunately we probably lost a person. And then we take a look at the homicides table. And then, yeah, there are like a couple of like coordinates here where that happened and where the neighborhood was. And so one way of checking that is, okay, let's just create a buffer, like an area around our broad station. So we do that with the buffer operation, and then you can check, like if you're into math, that this is almost pi r square of that. And then we can see, okay, we have now this buffer area, which is like almost like a circle of 200 meters around that station. Were there any homicides there? And we can kind of intersect those geometries and see if there is any information there. And then we got 1, not a so lucky person, I guess. And then we can see, okay, what are the streets nearby, doing a similar operation. And you say, okay, all these multi-polygons and stuff, let's just see some maps. So again, big shout out to Kyle Barron. His talk is like on Friday. But we're using Lombard here. Lombard make it very easy to plot things on Jupyter notebooks. And they have tons of geometries and polygons and stuff. I'm hoping that probably by the end of the sprint that we're going to be able to plot directly from an Ibis table. Like a couple of coworkers do it here, and others are kind of working on making this happen. But at the moment, we need to convert this to a GeoPandas data frame. And the way that we do that is with a method that we have in Ibis called toPandas. And toPandas, basically, when it sees that there is a geometry column, it will just do 2 GeoPandas, so it take care for that for us. So this is a bunch of conversions, nothing too crazy to see here. And here's where it gets interesting. Lombard allow us to kind of overlap multiple layers on a map. So then we get the scatters for the dots on the station and the homicide. Then we have a path layer for the street, and then we get a polygon layer for the geometry. So when we do that, we kind of get this cool map over here. It's if I zoom out, you'll see that, okay, this is New York City. And then I just zoom in, and then, yeah, we're in financial district. And then we have our station, our area around it, where the homicide happened, and in which street. So this is our unfortunate event. Now, cool, we see all this, and you say, great, Naty, but I don't have a DuckDB database. So I just have Parquet files that have some geometries, and then I would like to just process that. So how do we do that? So one way of doing that is, as of 3 weeks ago, DuckDB supports to read directly from GeoParquet. So then we can do that, and then without changes, Ibis will get you that. And here, what we're going to do is that we have a Parquet file that has a data from buildings, in this case, from a specific country, which is where I'm from. I'm from Argentina. So we're going to be plotting some building footprints. Big shout out to Matt Forrest. I took this idea from one of his videos. Source Cooperative has this data open. So this case, I downloaded because it was almost 2.5 gigabytes of data. And internet conference is not the best for demos, so I have it locally. But the way we do that is we read directly Parquet. So we read Parquet, then we can get the schema. So then you'll see here we have that geometry column, and then we have other information about it. This is about 33 million rows of data we have there. And we can do operations like the describe, that you'll do in pandas or something like it. It only takes a few seconds to go over 33 million rows. And then we have this geometry thing. So here the projection is slightly different, some sort of decimals. So that's why you see kind of the 64 and 23 and negative stuff. So one of the things that I wanted to see was, okay, the city I'm from, Cordoba, is the second biggest city. I wanted to see how many buildings there were there. So I just kind of got a coordinate on the center of the city, and then from there, kind of say, okay, can we just plot things around it? So I grabbed that coordinate. Ibis integrates very well with Shapely, so I can create a geometry point with Shapely and then give that into my queries and then do operations seamlessly. So we create that point, and it's Shapely has this plot that you can see geometries and points in Notebook. It renders really well. So the things that you can do are, let's check how many buildings are within an area of the center of the city. So we use the D within operation. And very quickly, we are kind of filtering all over those. Because we're going to be using this data quite a bit, we're going to just cache it. And then, again, we're going to use Lombard to kind of plot this stuff. And then in this case, we're going to be plotting about, let's see how many, approximately 800,000 geometries in a notebook, which is probably crazy to think of plotting before. We'll do the spiel of converting to pandas. As we said before, we need to do this. So running a couple stuff. And then let's just get that plot in. Okay, so we have a lot of buildings there. And say, okay, I can see much. Okay, I will zoom in. And then we keep zooming in. And this is right in the middle, of course. So you see all these little buildings over there flying around. And well, they're not flying, but they're there. So I was like curious, oh, cool, well, maybe I can find like the school where I study. So one of the things I did was, again, like another point, create like a geometry. And then I went to University of Cordoba, so I created like a little, like find where was the latitude and longitude, and then I'm kind of filtering buildings again around it, like around 5,000. Same thing, like converting to pandas and then using Lombard to plot. And then now we can see, okay, in that area, which is this mill Cordoba, and then I'm like gonna be zooming in. And I know this is my school, like over here, it's like School of Physics. And this is where I took my first class. I remember that building is like a huge round thing. It's called Batteries D. For some reason, we took it there. So yeah, and one of the nice things about this is, let's say that, okay, now we want to write that data somewhere. At the moment in Ibis that we're not able to write it, but like we're like interested in adding that. But DuckDB does. So I can just use it straight out of the DuckDB. So we can just connect again to our backend and then just pass raw SQL directly to write to, let's say, GeoJSON. So we're gonna write like kind of like this little map to GeoJSON. And one of the things I wanted to show is, let me see if I can put it here. VS Code has, whoops, wrong way. VS Code has this extension. For some reason I can't pass it, but okay, maybe I can't do that. Is it? No. Okay, it doesn't allow me to show it. I guess like if I do it quickly. Okay, let's see. Can we? Okay, it doesn't allow me to show you, but VS Code has this extension that you can actually provide the maps, and you can kind of like do right click and then immediately after like kind of see the rendering of the map. So if anyone is interested on that, some technical difficulties, it's not allowing me to move the map there. So, but yeah, it's a very, very cool thing. So you say, okay, now that you show me all these cool things, but it's just you playing with data, and again, you don't have any geo credentials or whatever. So what if I just tell you that there are some people doing like really, really cool stuff with this, things that are important. We recently kind of met this person. It's like Samir Lawani, who does something that looks like more like a real application. It's like antennas, optimal site selection. So he used to use like pandas and Dask and then get like these huge clusters and stuff to process this. And now because of Parquet and GeoParquet and then DuckDB, he can process all the, or most of this stuff like in his laptops. So one of the things he does is like try to maximize like the BID funding potential, which I was like, they didn't know what BID was. BID is like a broadband equity access and deployment program where the government basically is investing like an insane amount of money to expand like high-speed internet access around the US by funding planning, so he can optimize, okay, where to put these antennas to provide access to the most amount of people, and then this is using Ibis and DuckDB is spatial. So he sent me this slide. I was like, I can't see much of the code, but I'm going to find it. He's integrating like DuckDB, and then also recently DuckDB made really easy to install community extensions like Hex73H3, one of those. So, and he plots that, and then that makes things even faster. And when you go and then check, you have like here, Ibis code doing cool things that have a real impact and things to run fast, and now he can run this stuff on his laptop. So if so far I didn't convince you that these tubers are really cool and you can do really nice geospatial things, then, well, maybe you don't have a soul. And but hopefully I got somewhere there. And yeah, thank you very much. And this is all what I have for you. I will be posting all this stuff, and let's see if when you get out, I can get like that map looking. Here's where you can find the whole Ibis team in the internet, and you can find me also there. We have a Zulip chat, so if you're like trying things out and then want to play with it, please post there, bug us. We're gonna try to find all ways to like get back to you, open issues, open stuff. Like we're happy to talk to you. So, all right, Do we have any questions? Let's see if
Alrighty, open up for questions. Does anybody have one?
all right, question over there.
I noticed the library under Lawnboard has GPU support. Did you use the GPU in your demo?
No, I have not. And I also did not have GPU support, so that's like a very cool thing. Now, this is like just CPU or whatever is on my M2. Unless that by default is using some sort of GPU that might be on my M2, maybe that's a good question for Kyle. I don't think I did, so yeah.
Any other questions?
Over there, back in there, or here and there. Raise your hand high.
Yeah, just a basic question. The extension you mentioned, what's the name? The VS Code extension?
The VS Code extension, yes. It's called, let me see if I can try to get that on the board. It's called Geodata Viewer. If you have like too many geometries, it will just not render, but like it has some, so I'm gonna try to like, let's see if I can kind of like mirror my stuff and then get it. I think there was another one. You had a question?
The data itself, you're reading it through DuckDB, but was it all in kind of files outside of the DuckDB database? Or
For the first case or the second case?
either one.
So in the first case, like I had like multiple tables, so it was on a database. This is, okay. So in this case, I had a database called New York City Data Database, and then there are like 5 tables in it, and I was like kind of querying from there. In the second case, I have a Parquet file, and then I read that Parquet file, and that gets into like a table using DuckDB. So yeah.
Great, thanks.
Cool.
Is it possible to have a DuckDB instance that's running somewhere remotely, that's on a much larger machine, and basically connect to it and then run the query? Like
from your laptop connecting to it?
Yeah.
I mean, I don't know, because I mean that will be like trying to. I mean, I guess like if you connect, let's say, I don't know, via some SSH stuff and to some instance of whatever you're running, then I assume yes, but you will be running your code from whatever that database is. I don't know.
Yeah,
maybe
I was just thinking in transient, like if the database was transient, it was in memory, it wasn't really written out as a DuckDB file or a Parquet file.
So the database is not in memory. So like DuckDB is like, it's not like the database is in the memory. So probably the folks in the talk tomorrow, like they're gonna be explaining more like how like DuckDB architectures kind of stuff work, but it's not an in-memory database. It's like calling process, so then it's, you can maximize, basically the limitations of that is like your hardware, like not just RAM, but like also all your like disk. So, yeah.
Yeah, thanks.
Mm-hmm.
Any other questions? Right there.
Okay, this is the extension I was trying to show you, and now I like got it. So I did like right click on a GeoJSON and said add map, and then you can see now, okay, here is like, just kind of like zoom in and then kind of highlight the maps and then play with it. And this is just, needs a GeoJSON. You'll have it here, and I was just like, do view map, and then we have the map in there. You can add layers, add maps and stuff. If it's not too big. If it's too big, then it's gonna like break.
Hi, thanks for the presentation. So my question is related to GeoPandas. So you have shown me like lots of geospatial functions like buffer, within, intersection. So those are, I think, implemented in GeoPandas. So in Ibis, have you implemented those functions again in Ibis, or there is a dependency of GeoPandas?
No, those are all actually, the ones that you saw here, all the ones that I was doing, those are Ibis operations. and they are leveraging DuckDB on the back. These are not, they look like the pandas one, but they're not like they're not GeoPandas. The only part that we used GeoPanda was towards the end to do the plotting, but like when I did this filter, for example, here, this is like an Ibis function that is exploiting like the DuckDB geospatial backend. And we have support for about like 30 plus operations, but like if you say, hey, I would like to add this, and we will add it for you.
Something like geometry kind of operation, buffer.
Sorry, yeah, can you say that? I can hear like.
My question is related to like some of the geometry related operation like buffer within, not the filter one. Yeah.
Yeah. So let me see. Where do we have one? Here.
Yeah.
This one is, so if I show you here, broad station. So geom. This is like on Ibis. This is like the table on the Ibis stand, and then that buffer. If I do this, let's see. There we go. Can we see? Okay. There you go. So this is an Ibis function. This is not like a GeoPandas one.
Yeah. Cool. Thank
Yeah,
you.
Of course. Any
Awesome.
other questions, or I don't know how we're doing on time, but we're
Yeah.
probably at it. So thank you very much, folks. Like, feel free to catch me outside, and then we can keep chatting about it.